A chart, so we'll do the chart first and then we'll go back to the outline, because this is kind of the basic need to know. So this is what we did last time with chapter 31. So bone, it increases the calcium resorption by the osteoclasts. I said this is complicated because, yes, you're activating the osteoclast to release calcium from the blood, right? But vitamin D is also involved in making sure that bones are strong. So this is the mechanism of action. But if you think not only that you're releasing calcium into the blood, but that turnover of bone is important for bone strength, then that kind of makes more sense. In the kidney, so you get an increased conversion of 25-OHD to 125-OH2D. You increase calcium absorption by the kidney. So the more, this just means the more vitamin D you take in, the kidney makes more of the active hormone, and more of the active hormone increases the calcium resorption. And then in the intestine, you increase the absorption of calcium. So the parathyroid hormone also increases serum calcium levels. How does it do this? It increases rankle expression, which there's a really complicated diagram in the book, but that's just, again, the osteoblast talking to the osteoclasts. It's saying, okay, let's be more active. So rankle expression leads to an increase in osteoclast activity. What this is saying is we're low in serum calcium. The parathyroid hormone recognizes lowered serum calcium levels, and when that happens, the parathyroid recognizes lowered serum calcium levels. It recognizes that, it releases parathyroid hormone. Parathyroid hormone travels to the bone, which increases this signal, which tells the osteoblasts to tell the osteoclasts to get moving and release more calcium and also phosphorus because they go together from the bone. It also increases, in my non-legible handwriting, the enzyme activity of 1-alpha hydroxylase. That's the one that takes 25-OHD and turns it into 125-OH2D. So because we know that 125-OH2D can do this, and it can do this, and it can do this, so you're going to get more calcium coming in and being resorbed and being released from the bones, and then it increases calcium resorption. There are no direct effects of the parathyroid hormone on the intestine, but it does make more 125-OH2D, which then increases calcium absorption. So this is how the parathyroid hormone works with active vitamin D. Right? It increases this osteoclast activity on top of what's going on with active vitamin D. It increases the enzyme in the kidney, which produces active vitamin D, so there's more active vitamin D circulating, which affects how it works in the intestine. Because the more active vitamin D you have, the more calcium you're going to absorb. So you're taking more in, you're letting less out through the kidney, and you're releasing more from the bone. Okay, so you can get too much, and that's where calcitonin comes in. So the parathyroid, you've got the thyroid gland, and then you've got the parathyroid glands, which are these little ones, kind of, think of them as dots on the thyroid, like if the thyroid looks like this. Right, and you've got these parathyroid glands, right? So we've got two different types of cells. The calcitonin is released by what used to be called the parafollicular cells, and are now called the C cells. So the same way that insulin has, alpha and beta cells in the endocrine pancreas, right? Insulin and glucagon. We've got two different hormones secreted by two different types of cells within the same gland. So calcitonin lowers osteoclast activity, so you stop releasing as much calcium from the bone. The kidney inactivates calcitonin. So as it goes to the kidney can send it, it doesn't get recycled infinitely, because it's more important to have calcium than not have calcium. Too much calcium causes problems, but too little calcium, as you can see, can shut the whole system down. So once this is acted on the bone and is flowed around through the bloodstream, it hits the kidney and then it inactivates it. This is released in direct response to sensed lowered calcium levels, so it's a very quick response. So it's a quick release to get the osteoclasts to slow down, and then it's a quick breakdown. So you can it's a quick turnover system. Whereas to increase calcium levels, you've got two different hormones going on. You can consider this a hormone because it's an active form of something that's acting on other parts of the body So it's a signal to tell other parts of the body to do something else. So you have more of these to raise than you do to lower. But the flip side is calcium is excreted in the urine fairly quickly. So if you've got too much, it's going to go out in the urine. This slows it down. Otherwise, it's just going to go at a fairly good pace. Okay, so now let's go back to the outline.